So we're going to start our discussion with an early analysis of frequently made mistakes for assignment 2B. This is just the preliminary analysis. When we get all the submissions in, I'm sure there'll be more things that I notice that are problematic, and so we'll cover them. Remember, it's important to understand what these mistakes are because they have a habit of creeping in on various quizzes that we do. So first, please make sure, as always, that you document your code. People tend to be kind of sloppy that way, so please make sure you explain what it is you think you're doing. Please also make sure you address my comments from earlier assignments. And along those lines, make sure that all the unit and integration tests are passing. So as always, we keep adding new tests and new ways of improving old tests. So it's possible that what worked before for earlier assignments may no longer be working in your code because we've got better tests. And that's a perfectly legitimate way of improving quality of software over time as you improve the tests. So let's start by talking about the simple Semaphore class. So make sure that you don't try to use an atomic integer to keep track of the number of permits. That's too heavy weight for our needs. Instead, just use an int with the appropriate type qualifier that will meet the requirements that are stated above to ensure that the value that is stored in this field is not going to be cached by multiple threads. And you may need to go back and rewatch some of the earlier videos to see what I'm talking about there. Likewise, also don't just put sort of a naked int by itself. You need to qualify it with the appropriate type qualifier. And also don't doubly initialize fields. So here's an example where someone initialized the lock field to be a ReentrantLock with the value of true. That should actually be moved down into the constructor. Or at the very least, don't do it twice, because in this implementation, it was also being done in the constructor as well. Now let's go ahead and take a look at the acquire method. So what you need to do here is you need to go ahead and essentially acquire the Semaphore, which means that you want to decrement the count by 1, and you actually want to when you want to acquire it, you need to be able to decrement the count. So it should actually say decrement using the minus minus operator, and make sure that that works properly. Don't use the compare and set operation. That is not the right thing to do because you shouldn't be using atomic integer or atomic long here. You should just be using a good old int with the appropriate qualifier. The acquire uninterruptedly method is intended to be much simpler than this. This code is very complicated and incorrect for that matter. All you need to do is have a loop that calls acquire and then does the appropriate things depending on what acquire does. And we'll talk more about that here in just a second. Here's another implementation of acquire. And you can see in this particular case that you don't want to call the signal method inside of acquire. That's not what acquire does. Acquire waits until it gets the permit count to be greater than 0, and then it decrements it. And you need to reserve the use of signal for the release operator. And also, you don't need to have a catch clause here at all. There's no need to be catching these exceptions. Just make sure you have a try finally block. That's what you need. So let's put this back up here where it belongs. And then down here, here's another implementation of acquire uninterruptedly. And this is a little bit better than before, except that what you want to do is you want to make sure that you don't call thread.currentThread.interrupt inside the catch clause. Instead, you just want to set a Boolean flag. Do this one time, or rather, you're only going to call the current thread interrupt method once at the very, very end of the acquire uninterruptedly method after you've acquired the Semaphore. And you do it that way because that way you don't have to keep calling interrupt over and over again every time an interrupt occurs, which is unnecessarily expensive. And you also don't really know whether that interrupt flag could be cleared via the call to acquire because you don't really know what the semantics of that are. So instead, set a Boolean flag that's a local variable, and then check that once at the end, and then call the thread.currentThread.interrupt method in that case. And here's another mistaken way of doing acquire uninterruptedly. This needs to be called in a loop, as the specification indicates, and this code does not work properly. So it's got several problems as well. It's also got the same problem that we saw up here about not setting this flag. You only want to do that one time. Okay, so now let's talk about some problems with release. So release also does not need to have a catch clause, just like acquire doesn't need to have a catch clause. Acquire uninterruptibly does need a catch clause, but acquire and release do not. So there's no point in having that there. It doesn't help you at all. And this also is a mistake. This is problematic for a whole bunch of reasons. First, you shouldn't be using atomic integer. Second, release needs to increment the count, not decrement it. And concurrent set is absolutely the wrong thing to use. So all you have to do is do a plus plus on this thing instead of doing this complicated stuff here. Now let's turn our attention to the ReentrantLock hash map simple semaphore manager class, which is the other piece of the puzzle for assignment 2B. So this is actually fairly simple. Most of the stuff I'm going to talk about here is just kind of cleanup from problems that lingered on from earlier assignments. So first, make sure you use map and not hash map, and also make sure that you treat hash map as a generic type and use the proper syntax for dealing with generic types. This is not correct because it's not doing the generic syntax here correctly. And also get in the habit of using super type, which in this case is lock, not the subtype. It's just a good habit to get into when you're programming with Java often. If you're doing the grad student version of the implementation, make sure that you use a Java stream, not the for each method. And also, this is a pretty weird bug. This bug is trying to use the semaphore field to initialize the semaphore field. So it's trying to say semaphore.available permits in the act of initializing the semaphore field itself, which of course will not work because semaphore will start out with being null, and therefore you'll get a Java null pointer exception. So you have to figure out a different way to get the Palantiri count, and that's kind of a hint to figure out how to use the get Palantiri count method. Down here, we have a couple of problems with this code. This particular approach is redundant with the code above. We're calling set value twice, which is unnecessary. So please refactor this code to make it a lot simpler. This is if you're doing the Java streams version for the implementation of acquire. And likewise, if you're going to be using the Java streams version, then you either need to replace the use of get key with something that looks more like this, or even better, you should use set value up here. And what you want to do is you want to set the value to false, because we're saying that it's no longer available, and then have it go ahead and then continue to use get key. So kind of depends on how you want to do it. This approach here, but that uses set value to false, is a super, super clever way of doing things. And it's something I actually hadn't even realized until someone used it in their solution. So I doff my hat to them for being even more clever than I thought I was being clever. And then down here, if you do all the stuff I show you above and set the code up properly, there's no need to have to put the Palantir into the map. That is overkill, and you don't need to do that. You don't want to be calling the put method for putting something in the map inside of the acquire method for this class, because it is unnecessary and has extra overhead that you don't need. Now let's go ahead and take a look at some problems left over from earlier versions of release. So please make sure that you acquire the lock interruptibly as opposed to non-interruptibly. So you just have to make sure you call the right method on the lock interface. And then finally, and this is definitely left over from previous assignment, the replace method or the put method in this particular case can return three values. It can return the Boolean with a capital B true, the Boolean with a capital B false, or it can return null. And it'll do that under different circumstances. So null will get returned if the Palantir parameter that's passed to replace or to put is just nonsensical, but non-null. You'll get back a null because it won't be in the map. If you call the replace or put method with true and you get back true, then you have a problem because something has gone wrong with your Palantiri map. And the right value you want to get back is the Boolean value with a capital B, false. And you need to rearrange your code a little bit. And there's various ways to do this, but you need to rearrange your code to take into account the fact that replace can return 3 different values, because of course it's using a reference type with a capital B Boolean and not the lowercase Boolean, which wouldn't work anyway because you can't use native types for collections and parameterized types and so on, or generics in Java. So this is very subtle. Our unit test now will catch this problem. And so make sure that you're also taking this into account when you write the code. So that's the overview of assignment 2B's frequently made mistakes up to this point. And again, I'll put another video out later after I've had a chance to review more code. But please make sure you watch this video again and try to address these issues before you actually do the submission, because it'll make everything go much more smoothly when I have to review it.